times that gives us minus an AC. So therefore we have then that x must be equal to this term here, b squared x1 minus ab y1 minus ac all over ab times, we're going to divide across by this term here, so that's the same as inverting and multiplying as a fraction, so this is times ab over a squared plus b squared. Okay, they cancel, so this gives us, therefore we have our x must be equal to b squared x1 minus ab y1 minus ac all over a squared plus b squared. So the point of intersection, okay, so the point of intersection, okay, between L and M is, well, it's this point here. It's b2 x1 minus ab y1 minus ac all over a squared plus b squared, and the y coordinate, we have that here. The y coordinate, which we calculated a moment ago, okay, is a squared y1 minus ab x1 minus bc all over a squared plus b squared. So there you go. So now we have the hard bit, I think, done. Okay, we've calculated the point of intersection of L and M, where L and M are perpendicular to each other. Okay, there's the point of intersection right here. So now we have the point of intersection, and we have the point, and we also have, okay, we also have the point x1, y1. Why don't we calculate the distance between these two things? Okay, so let's say, so now let's calculate the distance between our point. Okay, so we need to use the distance formula. Okay, so our distance formula, don't forget, is it's x2 minus x1 squared plus y2 minus y1 squared. That's the square root of that. That's our distance formula. So let x1 and y1 be x1, y1, and let this be x2, y2. Okay, so let me just write this down again. Okay, so now our distance between them 2 points. Okay, maybe we should have given the points names. Okay, but sir, we have just 2 points in space. Okay, so our distance is going to be, it's x2, which is this term here. So it's, I'm going to write this down it's b squared x1 minus ab y1 minus ac all over a squared plus b squared. Okay, and what we need to take away from that is take away x1, which is x1. Okay, and that needs to be squared. Okay, and that needs to be squared, plus, and then we have the next term, which is y2, which is going to be a squared y1 minus a b x1 minus bc all over a squared plus b squared. Okay, and we need to take away from that y1. Okay, y1. So we need to minus y1, which needs to be squared. Okay, and it's this, I suppose it's the square root of this. So it's the square root of this guy here. Pretty big root. So we need to simplify this. Okay. What I'm proposing we do is just look inside the brackets first. There's a common denominator here. Don't forget that's over a 1, and this is over a 1. So the common denominator is a squared b squared. Okay. So this is going to become, inside the brackets, this is going to become, the common denominator is a squared plus b squared. Okay. So this into that goes once. So we're left with b squared x1 minus ab y1 minus ac. And it's minus x1 times this. Okay, so it's minus a squared x1 minus b squared x1. Okay, brilliant. And that needs to be all squared. Okay, plus over here the common denominator once again is a squared plus b squared. It's a squared plus b squared. So this into this goes once. So it's once times the numerator gives us a squared y1 minus a b x1 minus bc, and this 1 into the a squared b squared goes a squared b squared times, so it's a squared b squared times minus y1, which is the same as minus y1 times a squared b squared, which is minus a squared y1 minus b squared y1. Okay, that's what we get, and that's all to be squared. And I suppose it's the square root of this, so let me actually just put this inside a power to a half. Okay, hopefully we can see what's actually happening here. Is we have some terms that cancel out. The b squared x1 cancels here with the b squared x1s. The a squared y1s cancel with the a squared y1s here. Okay. So we're left with a couple of terms. We're left here with it's negative, so it's let's do it in terms of it's minus a b y1 minus ac minus a squared x1 all over a squared plus b squared, and that needs to be squared. Plus here it is minus ab x1 minus bc minus b squared y1, and that's a squared plus b squared, and that all needs to be squared. And then we have it's the square root. It's the square root of all of that. Okay. Let's just have a look at this here. There's a common term here. There's an a common here we could take out. There's actually a minus a common. Okay. So this would become. Okay. Let's actually fix our squares. So this would be the square root of a fraction is the same as the square root of the numerator and the square root of the denominator. So this actually is minus ab y1 minus ac minus a squared x1 to be squared all over a squared plus b squared to be squared. That's what that is. Plus, it's going to be minus ab x1 minus